Hi, welcome to 6.1 notes. This is actually going to be part 2, so it's going to be 6.1b, exponential growth and decay. So we're going to now graphing exponential growth and decay. So what is an exponential function? An exponential function has this basic parent function of y equals a times b to the x, where a cannot be 0, because anything times 0 is 0, and b has to be a positive real number, but it can't be 1. Now, I'm not saying it has to be greater than 1 or less than 1, because it could be greater and it could be less than. So take a look. If I have 2 to something power, start at 1, it doubles, right, to 2 cents, to 4 cents, to 8 cents. That's the exponential function we've been following. If it's less than 1, what happens is that you're dividing, right? So this is 1/2, which means you're multiplying by 1/2. So I start with 10, and then I cut it in half, and then I have 2.5, and then 1.25, right? So you keep cutting your number in half. So you can think of this as the same as 10 times 1/2 to the x power. So any number between 0 and 1 is exponential decay, and any number greater than 1 is getting bigger. I can't say fraction or whole number because growth could be, let's write this down. So exponential growth is when your base is greater than 1. It could be something like 3/2 to the x power, right? Like that's still growth. Decay is not just a fraction. It has to be a fraction between 0 and 1. Okay. It can't be negative, because if you have a negative number, you're going to have positive 1, negative 2, positive 4, right? And it doesn't make sense to have this graph that jumps back and forth between negatives. So it has to be positive. An exponential growth function is when b is greater than 1. We've talked about this a little. We should establish that if we were to make a function, or a table, of x values, let's go 0 in the middle, 1 and 2 for whole numbers. Well, 2 to the 0 power on your calculator is not 2 times 0, it's 2 to the power, 2 to the power of 0, and that's 1. Do you guys remember that we said, like, if there are no 2's, there's always an invisible 1 in front? So this is 1. 2 to the 1 power is 2. 2 squared is 4. To the negative, we talked about this very briefly at the beginning of the semester, but 2 to the negative 1 power means that it's just 1/2. And 2 to the negative 2 is 1/2 squared. So these numbers are always reciprocals. Okay, so here are my numbers. And I'll write it -1, -2. So what are we really graphing? We're graphing 0, 1, 1, 2, 2, 4. Well, whatever the base is, and this is if it's 2 to the x power, right? Whatever the base is, if this was a 3 to the x power, 3 to the 1 power is 3. So this one as an exponent, whatever the exponent of 1 is, that other number is your base. Okay. Whatever we start with here is always 1, because anything to the 0 power is 1. So these are the two numbers that we can always have, and just know that these are the numbers we start with. Okay. Decay is the inverse of that, or the opposite. So let's think about what a decay function looks like. Let's pretend like it's y to the 1/2 x. Okay. And so once again, I'm going to go with 0, 1, and 2 to start. So 1/2 to the 0 power is still 1. 1/2 to the 1 power is 1/2. 1/2 squared is 1/2 times 1/2, which is 1/4. Right? I'll write it over here. Okay, so the 1's multiply, and the 2's multiply. Okay. Well, if we said things to the -1 exponent, and -2 is just the reciprocal, right? I took this 2, and I made it 1 over 2, and the 4 became 1 over 4. That means I can work backwards and make 1/2, flip it to 2, and 1/4 flips to 4. So now I have a new graph. And when I plug in 1, I still get whatever the base is of that function. But this point over here, at -1, will always be 1 over the base. Okay. There's this thing called an asymptote that we should probably talk about as well. An asymptote is a line that the graph approaches more and more closely but never touches. So if you take a look at this number as we get smaller and smaller, right? If I go -3, it'll be 1 over 8. -4 is 1 over 16, right? And we keep multiplying the denominator by 2. That number gets bigger and bigger, which means that we're going to get closer and closer to this 0. However, it's never going to hit 0 because you can't ever divide by something and get 0. This is what we call an asymptote. This asymptote is at y equals 0. And why does it happen at y? Well, we have to look at not what axis it's on, but what number does it pass through. And it passes through right here as I go this way, my y-axis at 0. Okay? So this asymptote means that we're getting really close, but it's not going to touch. So when you graph, I'll talk about some things that you have to be careful of as well. Please always graph it. There's also an asymptote here, right? It's never gonna, we can never make it a negative number because b, if we take a look up here, b is always positive. So there's this asymptote at y equals 0. And it's the same line. You might notice that the 2 are flipped, right? So this is a horizontal or a reflection over the y-axis is one way to think of it from here to here. So let's talk about exponential growth or decay. Well, we talked about if the base is bigger than 1, that's growth. And if it's between 0 and 1, that's decay. So 1 over 12 is less than 1. So this is exponential decay. Because 1 over 12 is less than 1. That's my base. So this is growth because 1.5 is greater than 1. 7 over 2, 7 divided by 2 is 3.5. So this is growth because 3.5 is greater than 1. And then this one is decay because 0.8 is between 0 and 1. I should probably write that here too, right? So how can I write that differently? Instead of writing is between, I could write 0 is less than 1 over 12, which is less than 1. Pretty straightforward so far. Let's match each exponential function with its graph. And I want you to remember that this is always going to be at 0, 1. And the next one is always going to be at 1, comma, b. So let's take a look. This one, notice 0, 1. And then this one is 1, comma, 2. Uh-oh, I lost my light. Base equals 2. And so that's this one. Okay, A. Well, now I'm going to look for one that's growing. And for the next point, I'm looking for 1, comma, 3. Right? So that's my base. So let's take a look. This one's at 1, 4. That's this one. This is C. Let's cross out as we go. This one's the last one that's growing at 1, 3, which is F. And then when we look at decay, you can't figure out looking at 1 comma, like whatever it is. But when you're looking at decay, you're looking at the other side. So this side right here is 1 comma 4, or negative 1 comma 4, right? And if I had 4 to the negative 1 power, that is right here. Okay, so this one is E. Hopefully that makes sense, right? Here, let's see, that's one of them. This one on the left side is negative 1 comma 3. So that is 9, which is B. And then this last one must be D, but let's check it. We never assume. On the left side, that's negative 1 comma 2. So this is D. Okay. Okay, so now if I'm not giving you a graph, now let's learn how to graph exponential functions. We actually started this already. You are going to graph 5 points. Okay, and an asymptote. These are the 2 requirements that I look for. Now, if something doesn't fit, let's say the 5th point doesn't fit, that's different and you can leave it out. But if you can, you always have to graph 5 points. So we're always going to start with an XY table. And the 5 points are going to center at 0. And so y equals 2 to the x, where x is my exponent. I'm going to have 2 to the 0 power, 2 to the 1, 2 squared. And you can use your calculator to check these if you want. But I'm hoping that it'll become so fast for you that you won't need a calculator. Anything to the 0 power, I'm going to write this out, equals 1. That's a rule that I need you guys to just know. Okay, memorize it, say it to yourself, write it on your cheat sheet. So it's always 1. 2 to the 1 power is 2, and 2 squared is 2 times 2, which is 4. This side, I want you to remember that negative exponents mean reciprocals of positive exponents. So if I have 2, then the negative 1 means I'm going 1 over 2. And a positive 2 is 4. Well, 2 to the negative 2 is 1 over 4. And so we can graph this. What are these points? Let's write them out. That means my first point is negative 2 comma 1/4. That's a messy thing to graph. I have negative 1 1/2, 0 comma 1, 1 comma 0, and 2 comma, 1 comma 2, sorry about that, and 2 comma 4. So let's graph the whole numbers first. I don't know about you, but these are much easier. X and then y. Here's my x, here's my y. So in the x direction, I'm going 0, and then I'm going up to positive 1y. I'm going to go 1 in the x direction, and then positive 2 in the y, positive 2 in the x direction, and positive 4 in the y direction. The asymptote, notice this is actually a parent function. So even though there's a number now, exponential functions or exponential parent functions have to have a base. So this is the parent function because there's no addition. Nothing's being added, subtracted, multiplied, or divided. So we have this asymptote at 0 that we always start with because it's never going to become a negative number. Okay, and I'm going to write it there. 1/2, negative 1 in the x direction, and then 1/2 is just somewhere in the middle, and then it's going to get smaller. Now we don't actually want to touch, so you want to be really careful. Draw your line above, but the thing is you can't have it curve up either. An asymptote says it gets closer and closer. So what happens if you can't get closer? Just draw an arrow. Okay? Let's try another one. So this one looks almost the same, but there's a +1. Hopefully you know that this is a translation up 1. Okay, so we're going to ignore that. We are going to do this function first. Make a table. Okay, because once you add 1, it gets messy and things happen in your head that you might mess up on. So I'm going to focus on y equals 3 to the x only, because that's my parent function. I'm going to go from -2, -1, 0, 1, 2. And so ignoring the 1, 3 to the 0 power is 1, 3 to the 1 power is 3, 3 squared is 9. And once I have that, I can take the reciprocal, 1 over 3, 1 over 9. So I'm going to graph my parent function, and then I'm going to shift it up 1. Another thing you could do also is just take all of your y values, because I'm moving it up, right? And y is up and down. You could just add 1 to each of these. I find it a little messy doing it that way. So here's the first one, 3, 9. Okay. And I'm not going to connect the dots because it's apparent. Here's where we started. And I'm going to take each of those points and I'm going to shift it up 1. Another thing you can do is shift your asymptote as well, right? So if I move it left and right, nothing happens, but I'm just shifting up. So that means my asymptote has to move as well. And how I do this is I actually don't move and count these, because if I count up 1, like let's say we have to count over 5, decimals become messy. But if I move this point, then I know from here to here is up 2 over 1. So the red to red is up 2 over 1. And then I know like this blue point is like half, right? So I just go down half and it's going to hover right above the asymptote. So this one in red is f of x. Okay. So how does it look when we do 1/2? Well, we're going to do the same thing. Table of values to the x power, -2, -1, 0, 1, 2. So 1/2 to the 0 power is still 1. Anything to the 0 power. 1/2 to the 1 power is 1/2. 1/2 times 1/2 is 1/4, because that's what 1/2 squared means, right? Notice I didn't need a calculator for this. If you put it into your calculator, you do have to be careful. 1 over 2 to the power of 2 does not... Oh, I guess it worked. Okay, that worked. I, to be safe, would have done this. It would not work if it was 3 over 2. Let me show you why. Okay, so we would expect that 3, let me just do a sidebar real quick. 3 over 2 is squared is really 1.5 squared, right? So if I did 1.5 squared, notice that is not the same as that, okay? Because what your calculator did was 3 divided by 2 squared. That equals a 3 over 2 squared, and it didn't square the 3. So you have to use parentheses around the whole thing. So these two are not equal. Okay. But to go back to fractions, take the reciprocal. So that'll be 2. 1 over 4 is the same as 4 over, reciprocals to 4 over 1. Let's write out our points. -2, 4. -1 is my x. 2. 0, 1, and then 1, 1/2, and 2, 1/4. I know since I didn't add or subtract anything, my asymptote is still at 0, 0. No shifts. So this is a parent. But how come we have so many different parent functions? There's a parent function here. There was one over here, right? So any base without any addition or subtraction, that base to the something power is your parent function. So let's see. -2, +4, -1, +2, 0, up 1, and then 1, 1/2, and then 2, 1/4. And so our function is now going in the opposite direction, going down. Okay. Get close to the asymptote, but don't touch it. And this last one is the trickiest. What do I do when there's a 2? Well, that's my vertical stretch. But I'm going to use this as my parent function. Well, we've done that one already, like a bunch of times, but let's see if you guys can do it yourself. -2, -1, 0, 1, and 2. Take a moment, see if you can fill in the table yourself. Not with the 2 times, okay? So this is really important. I don't want you to plug in numbers to this function using your calculator. I want you to plug it into just 2 to the x. Okay, that's the parent function. So 2 to the 0 is what? 2 to the 1 power, 2 squared, and then reciprocals. So let me graph these. 0, 1, 1, 2, 2, 4. And if it's a vertical stretch, vertical is my y values, correct? That's up and down like this way. That means all of my y values are going to be multiplied by 2. So what do they become? Well, instead of 1, 2, it's going to be 1, 2 times 2 is 4. This one will be 2, 8, right? 4 times 2. Now be careful, when we do 1 times 2, that's fine, 0 times 2. But this side is no longer 1/4, or -1, 1/4. It's 2 times 1/2, right? So be really careful. Once you have a vertical stretch, you're not just taking the reciprocal anymore. If I take a half and I stretch it, it's going to become 1, right? Because these two cross out. So this will be -1, 1, and -2, 1/2. So this one stretches, this 2 stretches by multiplying by 2, and this 4 stretches to an 8. And let me connect it. This one's still a decimal. This one is f of x. Okay, you see how we stretched up. Our asymptote doesn't stretch, because if I'm at 0 and I multiply 0 by 2, this is still y equals 0. Okay. Well, try your homework, see how it goes for you, and let me know if you have any questions.